Today our lesson is on solving systems of linear inequalities. So the first thing that we're going to do is go through this background information. So to use a graph to find the solution set of a pair of linear inequalities in two variables is our goal for today. Two or more linear inequalities form a system of linear inequalities or simply a linear inequality system. A solution of the system of linear inequalities is an ordered pair consisting of an x and a y coordinate that is the solution of each inequality in the system. So it would have to work for both of them. The graph of a system of linear inequalities is the graph of all solutions of the system. Now, as a reminder, okay, we have the boundary line of the half plane is a dashed line if the inequality is less than or greater than without those equal to lines underneath, and it would just look something like this, a little dashed line. However, that boundary line will be solid if the inequality is a less than or equal to or a greater than or equal to, and then it will just look like a traditional solid line, like that. So let's take a look at our first example. Let's see if I can enlarge this a little bit. Okay. So when we go to graph the system of linear inequalities, we want to, at first, just graph each of the two equations, or in this case, inequalities, but we almost pretend that there's an equal sign there when we do it. Now, the y is greater than or equal to 2. There's the equation here, it's just a y inequality. There's no x in it. So this tells us this is going to be a horizontal line. And always remember horizontal looks like the horizon, so it's kind of going this way. So to graph this, I would find the 2 on my y-axis, since it's a y inequality, and I'm going to draw a solid horizontal line through that point. Now, if I think about it, every single one of the points on this horizontal line has a y value of 2. So this would be like 1, 2, 2, 2, 3, 2, and so on. Over here, negative 1, 2, negative 2, 2. And so that's why I know it's going to be horizontal, because all of the y values on that horizontal line have the same value of 2. Now, because this is an inequality, we have to take this extra piece or extra step, and we have to do some shading. So to do the shading, we look at the y, and then we look at the inequality sign. Now, if it's opening up towards the y, that means that y is greater or equal to 2. So look at my y-axis. All the numbers on the y-axis that are greater or equal to 2 would be above that line. So that's why I shade up here. So now when we go to the second inequality, which is this x one, this is going to give us a vertical line. And the vertical line is straight up and down. So now we find the 3 on the x-axis, which is over here. But instead of drawing a straight, solid vertical line, I'm going to draw a dashed or dotted vertical line. Because, notice, the inequality sign does not have the equal to underneath of it. So that means it cannot equal 3. It can only be less than 3. And all the points on this line that I just drew have x values of 3. And we know that ours cannot equal 3, can only be less than 3. So it's just a boundary line to kind of show us our cutoff point, but none of the points can actually equal it. So that's why we don't actually make it solid. But now x is less than 3, and all of the x values on the x-axis that are less than 3 are over here on the left. So that's where I'm going to shade. And then you just shade everything on that same side. If you have a highlight or something, it works a little bit nicer and it looks a little bit better. All right, so now when are we finished? Well, we're not finished quite yet because we have to find some solutions, or at least the area that contains the solution. So when we do these two inequalities, we notice that there's this one section of our graph where both of the shadings kind of overlapped. So in the blue shaded area, those were all the solutions to my first inequality, and the pink shaded area was all the solutions to my second inequality. But where they overlap is solutions to both, so that would be solutions to the system. So to check my answer, I'm going to pick just any point in that double shaded area. So I try to pick something easy. So I see my origin is there, so maybe I'm going to pick 0, 3, for instance. Now, if I pick the point 0, 3, I would just need to check it for both of these and make sure it makes them both true statements. So my y value here is 3, so this is saying 3 is greater or equal to 2, which is true. Now I'm going to check it with my my x inequality. So if the x is 0, 0 is less than 3, which is also true. So I know that this particular point, 0, 3, is one of the solutions. You wouldn't have to pick that one necessarily. Obviously, you could pick any point. So you want to pick this one up here, it's 10, 10. Or you could pick, let's see, 1, 1, 2, 3, 4, 5 right there. Or maybe you want to pick 0, 8. Or you could pick -3 and I don't know what that is. Let's say 1, 2, 3, 4, 5, -3 and 5. So it doesn't really matter. Any of those points should work and be solutions of your set. So let's take a look at the next example. Same idea, but this time when we graph these, they're just going to be traditional, slope-intercept type form equations, or in this case, inequalities. So my slope is always that number in front of the x, which in this case is 2. And if it's not a fraction, I put it over 1. My y-intercept is 1. So to graph this, I'm going to begin at the 1 on the y-axis, and then I'm going to move up 2 and 1 to the right. Up 2 over 1, up 2 over 1, up 2 over 1. Or I can go down to left 1 to continue in the opposite direction. Now, before I just go ahead and draw a line through my points, I need to check that inequality sign. But I'm noticing that this inequality sign does not have the little bar or line underneath, so I know I'm just going to be doing this dashed line because it's just a boundary line, but none of these points are actually solutions, so we're just using it as a cutoff. So now to do my shading, since y is less, right, because this direction of an inequality sign means less than. And the way I remember that is because when I'm reading it, it kind of looks like an L that's just tilted a little bit. So the L starts the word less, or it starts the word low. So I know all the less than numbers are lower or underneath. So I'm going down that y-axis since y is less than the line. And then you just fill in everything else on that side. So now when we go to do the second inequality, this time my slope is 1/2. And I don't have a visible y-intercept so that I know that it's 0, or I'm going to begin at the origin. Then I'm going to go up 1 and over 2, up 1 over 2, up 1 over 2, up 1 over 2. Or I can go down and to the left 2 to continue making points all the way across my coordinate plane. This time, my inequality sign has that line underneath indicating it's a greater than or equal to, which means I'm going to do the solid line through all these points. So all those points are not only on the boundary, but they're also included on this inequality here. And then I'm going to shade this time. I have a greater than sign. So I'm going to shade up the y-axis. So all the numbers that are greater on the y-axis would go up. Like as you go up, you get higher and higher on the positives. As you go down, you get less than or lower. So we're going to shade up the y-axis and then continue shading anything else on that side. And then we're looking for our solution set. So our solution section of this graph is over here in the double shaded section. So then pick a point that's in there and check it. So you can pick anything that's in this double shaded section or even on this portion of that pink line. I usually like to pick one that's inside somewhere. So I'm going to go to 1, 1. That point right there looks like it might work. Or maybe 3, 3. Or maybe 4, 1, 2, 3, 4, 4, 5. So really, it doesn't matter. So I'm going to just do 1, 1 because those are nice, easy numbers to work with. So if I choose 0.11, I would put 1 in for my y. I'm going to check the first inequality first here in the blue. Then I have 2 times 1 plus 1. So that gives me 3. 1 is less than 3, so I know I'm good there. So now I'm going to check the second inequality. So I'm going to put in my 1 for y and my 1 in for x. So I have 1 is greater than or equal to 1/2, which is true, so it works for that one as well. So that tells me that that 0.11 is one of the solutions for this system of linear inequalities, as well as all of the other points that are in that double shaded section there. All right, so moving on. All right, so then when we go to graph the next two, same process here, right? Now these are all nicely set up for us in the slope-intercept form, so we can really focus on the shading, the dotted line. We don't have to worry so much about getting the y by itself just yet. So here our slope is always that number in front of the x, which in this case is a -1, and I like to put it over 1 since I'm going to do rise over run. And my b value is 4. So I'm going to begin at the y-intercept of 4. 1, 2, 3, 4. And then since I have a negative slope, I'm going to use that on my top number. So I'm going to go down 1, but still to the right 1. Down to the right, down to the right. Remember, if you have a negative slope, your line should be falling as you go left to right, should be going downward. So you can always do a visual check. Whenever you have a negative slope, you should be expecting a line that goes down. If you have a positive slope, it should be going up. This does have the equal to underneath my inequality sign, so I'm going to draw a solid line there. Sorry, I kind of had a little snag there. And now we're going to shade it. So when we go to do our shading, y is greater than or equal to, so the numbers greater on the y-axis are up here. So that's why I know I'm shading this side of the line. All right, now I go to my second inequality. My slope is a +3 or 3 over 1, and my y-intercept is +1. So I'm going to begin at the 1 on the y-axis. I'm going to rise 3 and run 1 to the right, up 3, 1 to the right, up 3, 1 to the right, or I could go double negative, down 3, 1 to the left. This inequality does not have the equal to line underneath it, which means the points on the line cannot be solutions, so I'm just going to have to do this dashed line here. Dashed or dotted, whatever you want to call it. And then finally, I'm going to do my shading. Y is less than, so the less than y values are down here. These are all my negatives. So all the numbers are getting less than or lower. And then I just continue shading everything on that same side of that dark pink line. And then finally, I identify the area of the graph that contains all my solutions, which is this double shaded section. Pick any point you'd like from that section. So I'm going to pick 1, 2, 3, and then 1, 2, 3, 4. So I picked point 3, 4. But you can pick anything you want in that area. It might even be easier to pick a point that's on a zero, like 0 or something. So here we have 1, 2, 3, 4, 5, 6. Like this would be 6, 0. Or over here, 0, 1, 2, 3, 4, 5. This, oh wait, that's not in there. Sorry about that. Never mind. Yeah, so we'd have to pick 6 first. So you can do whatever you want, but I'm gonna just switch it to 6, 0, because whenever we have a 0 in there, it's usually pretty easy to plug in. So to check the first inequality, we're putting the 0 in for y. And then I have a negative 6 plus 4, which equals negative 2. 0 is greater than or equal to negative 2, so I'm good with that one. So now I check my other inequality. I'm putting in 0 for the y again. 3 times 6 plus 1. 0 is less than 19, which is obviously true. So it works there as well. Okay, a couple more of these. All right, so next one, again, this time we have a negative 1/2 for our slope. So remember that negative is only on one or the other. So you can either treat the numerator with the negative or the denominator. So I always put it on the top. And then my b is 2. So I'm going to begin at 2 on the y-axis. And because I put the negative on my top number, I'm going to go down 1, but still to the right 2. Down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. If you put the negative on the 2, then you would have gone up 1 to the left 2. But notice those points are on the same. You do have the equal to on your inequality symbol here, so you're going to do a solid line through all those points. And now for shading, y is less than the line, so all the y values that are less than the one on the line are down here. Okay, so now let's go to our next inequality. Our slope here is 2, or 2 over 1. Our b, or our y-intercept, is negative 2. So beginning at the negative 2, and then I'm going to rise 2, go over 1. Rise 2 over 1, rise 2 over 1, continuing all the way across my coordinate plane. And again, we have an inequality sign with the line underneath of it, so it's going to be a solid line. And y is greater than the line, so all the y values, so we're only concerned about the y-axis, the y values that are greater are going up. And then we continue still shading that side where. And then we look for our solution area, which is the overlapped shaded area, and then pick a point and check it. So 0, 0 is actually in that section, so I'm definitely going to pick that. So if I check it for my first inequality, I would have 0 is less than or equal to negative 1/2 times 0 plus 2. We know 0 times anything cancels out, so we're just left with 0 is less than or equal to 2, which is obviously a true statement, so that's good so far. Then I'm going to put it into the second inequality. So 0 is greater than or equal to 2 times 0 minus 2, which just gives me 0 is greater than or equal to negative 2, which again is a true statement. It's confirmed that 0, 0 is in the solution set. So chances are we did graph this correctly. Okay, so we're going to continue on with this. The only trick here is that now these were not given to us in the slope intercept form. So we're going to just have to do that extra step first. So I'm going to look at this equation here first, or inequality. So I want to get my y by itself. So I'm going to subtract my x. So I have 2y is greater than or equal to negative x minus 2, dividing everything by that 2. I have y is greater than or equal to, now remember this is really a negative 1 here, so negative 1/2 x, and negative 2 divided by 2 is negative 1. So this is my first inequality. And then I'm going to take this one and write it over here so I have some room. So we're going to subtract the x. We want to get that y by itself. So I have 2y is less than or equal to negative x plus 2, dividing everything by 2. So I have y is less than or equal to, again, this would be a negative 1/2 x, and then that's a plus 1 there. Okay, so now it's the same thing that we were doing on the other side. So I'm going to take these two inequalities, I'm going to graph them. So for the blue one here on the left, I know I'm going to begin at the -1, and then my slope is down 1/2 to the right. So down 1/2, down 1/2, down 1/2. Or I can go up and to the left. Now there is an equal to underneath my symbol here, so that means I can just do the solid line. It's a little squiggly there, but you're going to have to bear with me on that. And then for the shading, y is greater than or equal to, so that would go above the line up the y-axis for my shading. All right, so now let's do the second inequality. +1, so we're going to begin at the +1 on the y-axis, and we're going to go down 1/2. Remember, when there's a negative, it's only applied to either the top or the bottom of the fraction, so I'm going to put it on the top, so I go down 1 and then 2 to the right, down 1 and 2 to the right, down 1 and 2 to the right. And you might notice this is ending up that these two lines are parallel, which isn't that surprising considering they had the same exact slope. Now here again, we're going to do a solid line because of that equal to underneath. Now when we go to shade here, y is less than, so we're actually going to go below that line when we shade. So notice the overlapping section is this skinny little sliver in between those two parallel lines. So when we go to identify a point from our solution set, it's got to be somewhere in here. Now the origin is in there, so that's probably going to be your easiest point to pick and check. But any other point in there would be fine. So any other point in this double shaded section, even points on the line itself, because both lines were solid, those would also be legitimate. So to check the first one here, I have 0 is greater than or equal to -1/2 times 0 minus 1. Anything times 0 cancels out, and 0 is greater than or equal to -1. So we're good there. And when I check the next one, 0 is less than or equal to -1/2 times 0 plus 1. 0 is less than or equal to 1. That works out as well. So that's it. That's our answer, that shaded section in between those two lines. Okay, so example B, same idea here. Let's try some different colors so that we can mix it up a bit. So this first one here, I'm going to recopy and do over here just so I have a little bit of room. So x minus 2y is greater than or equal to 4. Again, we're getting that y by itself. So I'm going to move my x over by subtracting it. -2y is greater than or equal to -x plus 4. And now everything needs to be divided by -2. Now remember your inequality rules. When you divide by a negative or multiply by a negative, you must inverse your inequality sign. So this is going to flip directions here. Then we end up with a +1/2 x and a -2 for the rest of our inequality. All right, so now on the other side here, I'm going to do this equation or inequality. Subtracting the 2x from either side, I have -y is greater or equal to -2x minus 2. And again, same idea. I'm going to divide everything here by -1, or I guess you could multiply by -1 as well. And we get y is less than or equal to, I had to inverse that inequality sign, +2x plus 2. Okay, so now we're going to graph these two. So starting with this one here in the purple, I'm going to begin at the 2. My slope is +2/1, so up 2/1, up 2/1, up 2/1, up 2/1, or I could go down to 1 to the other direction. And it's going to be a solid line because we do have that equal to piece underneath. Now, as far as shading is concerned, y is less than, so I'm going lower than the line down the down the y-axis, and that is the side that's going to get shaded. Now, when I go to graph my second inequality, I'm going to begin at -2, and then I'm going to go up 1 to the right 2, up 1 to the right 2, based off of my slope. And I also can go down and to the left 2 to kind of get my graph to go all the way across the coordinate plane. Still get to use that solid line because we have the equal to on our inequality. And this time when I go to shade it, y is less than again. So again, I'm going to go less than or lower than that green line there. So the section that was double shaded, or where the shading overlapped, was down here. And then pick any point you want. So maybe I want to pick this one. There's some nice zeros in here. Maybe I want to pick this one. So this one is 8, 0, or over here I have 0, 1, 2, 3, 4, -5. Whatever you'd like to pick, okay? So I'm going to do 0, -5. So for the first inequality here, put the -5 in for the y and 0 in for x. That gives me -5 is less than or equal to 2, which is true. Then when I try my other one over here, I'm going to do the -5 for the y again. 1/2 times 0. That's why I really love 0 for my x, because it cancels out the fraction. And -5 is less than or equal to -2. So I know I'm good once again. All right. So we got another one here. Same idea, just a little bit more intense of a equation. But we're going to go ahead and start it out by getting that y by itself. So I have 4x plus 2y is greater than or equal to -6. Again, moving that x over to the other side using the inverse operation of subtraction. I have -4x minus 6. Dividing everything by 2. Now, because I'm dividing by a positive 2, I don't have to change the direction on my inequality sign. And I get -2x minus 3. Now, to do the other equation here, I'm going to subtract the 8x. And we already have a single y, so now it's just -8x plus 3. Again, didn't have to worry about reversing my inequality or anything because it did not divide or multiply by a negative. So now when I go to graph these, beginning at the 3, 1, 2, 3, and my slope is -8 over 1. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, and to the right 1. If I have more room, I would go down another 8 over 1, but I'm kind of out of space for that. If I go up 1, 2, 3, 4, 5, 6, 7, 8 over 1, I'm kind of just off the graph. It is a inequality sign without the equals, so this would just be a dotted or dashed boundary line. Okay, so now with the shading for this one, y is less than, so that would go below. Now this line was almost vertical, so it's kind of hard to tell, but find the y-intercept and go down from there if it's a less than. You can always start at that y-intercept. Okay, now the second inequality here, down 3, 1, 2, 3. And my slope is -2, which is really over 1. So down 2 over 1, down 2 over 1, or up 2 left 1. And because my inequality sign this time does have the line under it, I can do a nice solid for that one. Now, as far as my shading is concerned, y is greater, so I'm going to find my y-intercept and then go up. And then everything else that's on that same side of that line. All right, so at this point, you can now see your solution area is in this top portion there. And so you can pick a point in that section. So maybe it's kind of hard to see if this is orange here. So I'm going to do -1 and 1. Okay, and then we can just check it for the 2 and make sure it works. So for the first one here, I'm going to put in a 1 for my y, right? And then I'm going to have -8 times -1, which is going to give me a +8, and 8 plus 3 is 11, and 1 is definitely less than 11. Then when I do my other one over here, I'm putting in the 1 for y, the -1 for x. Negative times a negative is a positive, and 2 minus 3 is -1, and 1 is greater than or equal to -1. So I'm good again there. All right, so going on to this one. Now notice this time we have 3. So it doesn't change too much. We're just going to have that third one in there. So I'm going to start them out. So this one here, I'll put it all the way over on this side. So we have 2x plus y is less than or equal to 4. Again, we need to get the y by itself. So we're going to move the 2x over. And we have y is less than or equal to -2x plus 4. Do not have to change the direction of any inequalities or anything because that we didn't divide or multiply by negative. So now this one, I'll do right here. So we have -3x plus y is less than 3. And then we're going to add the x over to the other side. So we have y is less than 3x plus 3. And then our third one is just going to be this here, which, if you remember from the first problem we did, will be a horizontal line. So let's go ahead and do that one first. So when we go to graph it, we want to find the -4 on the y-axis. We're going to do a horizontal line, and it will be a solid horizontal line because we do have that equal to underneath there. And then when I go to shade it, y is greater than -4. So that tells me everything up here is going to be shaded. All right, let's go to our next one here. So I'm going to begin at the 3, and then I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1, or I could go down 1, 2, 3 to the left 1. 1, 2, 3, 1. 1, 2, 3 left. 1, 2. Okay, now this one, if you remember the inequality sign, it did not have the equal to underneath, so I do have to do a dashed or dotted boundary line for that one. And then when I go to do my shading, since it's a y is less than, I'm going to find the y-intercept, which is at the 3, and I'm going to go down that y-axis, so it's all over here. And finally, I have my third inequality. I'm going to begin at the 4, 1, 2, 3, 4. I'm going to go down 2 over 1 because that's what the slope is telling me to do. And this time I can do a solid boundary line because of that equal to underneath. Sorry, a little crooked there. And then finally, my shading is going to be less than that. So I have to go to that line, look for my y-intercept, and I know that I'm going to go less than that, but make sure you're staying within under that particular line. So it's actually going to look like this. All right, now it's a little bit messy here because all these colors are overlapping, but you can see that all 3 of them overlapped in this central little triangle where the origin was a point in there. So that's nice because I can now check the origin. And when you check the origin, you would have to check it, or whatever point you chose for all three. So if I go to check it for here, 0 is greater than or equal to -4, that obviously works. If I check it for this one here, I get 0 is less than 3, which also works. If I check it for this equation, or inequality, I keep saying equation, 0 is less than or equal to 4, it works there as well. So we can confirm that that central part of that graph is indeed the solution area. All right, and then the last thing we're going to go over is how to write the system of linear inequalities based on the region that's shaded. So the first thing you need to do is figure out your slope and your y-intercept for each of the lines. So I'm going to do this one first here in the blue. Okay, so if I look at this one, I see that I have an m, or a slope of up 2/1, and my y-intercept is -2. So at first I would write y equals 2x minus 2. Now, because it's a solid line, I know I'm going to have an inequality with the equal to underneath. But where was this shaded? It looked like it was shaded up the y-axis from there. So that means that the y was greater than or equal to 2x minus 2. Now when we go to do the other line right here, first things first, find your y-intercept. This one also happens to have a y-intercept of -2. The slope this time, though, we're going down 2/2, or down 1/1. So I would have y equals -x minus 2. Now, again, it's shaded up the y-axis from that line. So y is greater than, and I can keep that second part of the equal sign, the equal to underneath there, because the line is solid. All right, so let's try B. All right, so I'm going to first highlight this line here. All right, so let's try this one first. Again, they're both solid, which is kind of nice. So this one here, my y-intercept is -2, and my slope is definitely a negative slope, and it looks like it's going down 1/1, down 1/1. So my slope is -1. So this equation is y equals -1x minus 2. Well, we have to check that. It's not an equal sign, right? Because there's shading, but the shading is going up the y-axis, which tells me its y is greater than or equal to -x minus 2. So now we do this line here. Okay, finding the y-intercept, which is 4. The slope here is also -1. You might have known that just because they're parallel lines, or you could simply check your rise over run. Y equals -x plus 4. This time, though, the shading is downward, so you would have to do y is less than or equal to -x plus 4. And those are your two equations or inequalities. So this would be the system of inequalities you had for this one. And over here, those would be your two inequalities. All right, so let me skip down to E because that's dotted. So if we go to this one, both of these are dotted. I'm going to do this one here in the red first. So this one had a y-intercept of 1. And the slope is up 2/1, and it's going positive, so I know that's a positive slope. So first I would write y equals 2x plus 1. Now, the shading is going down, so that tells me it's going to be a less than. But I have to erase this little equal to line because it was dotted, so it's just going to be a y is less than, and then that's it. Okay, let's do the other one here. Again, it's going to be dotted, so it'll just be a greater than or a less than. It's going down again, so I know that's actually going to be a less than. All right, so let's find our y-intercept. Once again, our y-intercept is 1. This time our slope is down 1 over 2, so that's negative 1/2. So this is going to be negative 1/2 x plus 1. So these are the two inequalities of that system. All right, I'm going to do one more with you today. So this one here, we have the b, or the y-intercept, which is, let's see, 1, 2, 3, 4. The slope here is definitely going upward, so it should be positive, up, let's see, up 1, 2 over, wait, up 1, 2, 3 over 4. And then this is shaded upward, so we know y is going to be greater. It's not greater than or equal to, though, because the line is dotted. And then we have 3/4 x plus 4. That's one of the inequalities in our system. Then we go down here and find the other one. So this one has a y-intercept of negative 5. The slope should still be 3 over 4 because they are parallel lines and it's still positive. But this time the shading is down, so y is less than 3/4 x minus 5. And of course, there's no equal to on that inequality because, again, it is a dotted boundary line. And hopefully this will help you guys understand how to graph and shade those linear inequalities to solve a system.